So, just this week, I think that you might be interested in this information. Your the power of composition talk was translated into Russian, and actually, your talks are one of the most commended and from the talks that I translate personally, and I think it was patterns of functional programming that was hugely commended, and I even needed to translate another article by Bob Martin to actually make a point that it was a joke, that it doesn't mean that anything is a function in functional programming, because people were so mad about it, saying like, oh, you can tell that you can tell people that everything is class and object-oriented programming. So anyways, well, we're doing some progress here to translate your website, and I'm a big fan of your website, and I'm eager to hear for what you will be presenting today.
Thank you so much. Yeah, I was here. I was at .next, I guess, in Moscow 2 years ago, was it? That was a really great experience. I'm very glad to be back here. So thank you very much for having me. Right, I think we should start now, yeah?
Yeah.
Okay, very good. So let me get the slides up. Here we go. And so this talk is called Designing with Capabilities. And if you don't know what a capability is, I will explain it. So my Twitter handle is Scott Wlaschin, if you ever want to contact me. And as you mentioned, I have a website, F# for Fun and Profit, and the slides and the videos will be available on the website as well. So I think a lot of people are familiar with domain-driven design, DDD, and a lot of people are also familiar with security, and people are familiar with how to design an API, and they don't normally think of them as intersecting. But this talk is going to be about the intersection where they all meet up together. So that's what this talk is about. And when I mean security, I don't mean OAuth or JavaScript web tokens, any of that stuff. I mean designing for security. How do you make a system safe? So we're going to borrow some stuff from security, and we're going to use those ideas from security to improve our API and to do some nice domain-driven design. So let's see how that works. And by the way, I just want to say I am not a security expert. I am just a regular programmer, and I think there's things we can learn, but please do not trust me to harden your infrastructure against hackers. That's not me. So I'm going to first of all start off, what does security have to do with design? And then I'll talk about what are these capability things and why are they different from any other way of doing things. And then I'll talk about how we can actually use these capabilities to design an API. And then I'll also talk about all different other ways that capabilities are really useful, that can really help you think differently about designing your systems. So I guess that's the thing I want to come across, is it's a different way of thinking. I mean, we're used to object-oriented programming, and a lot of people are used to functional programming. And this is yet another way. It's a way of thinking about designing your code to get certain benefits that you wouldn't get if you didn't do it this way. So let's start off with security. And what does security have to do with design? We normally think about security as locking things down. So let me give you an example which has nothing to do with programming. Let's say you have one of these envelopes, and I think you've seen the envelope itself is white, but there's a little kind of transparent bit in the middle. And these are normally called security envelopes. You can't see through the envelope except this little bit where it's transparent. And the idea is this is about security. And the idea is you cannot see any of the letter. You can just see the address. That's the only thing you can see. So it's a security thing. But let me give you a counterexample of why it's not just about security. Here is a letter. And let's say I do not care if you see it. I don't care. There's nothing secret in this letter. But I want you to deliver this letter for me. And you say, well, where should I deliver it to? Right? It's not very obvious. It's not at all obvious what I should do with this letter. But if I mask out all the rest of the letter and I just focus on this little bit here, it makes it easier for you. This is a better design. This is not to do with security. This is just making your life easier because you're being forced to look at the important things and you can hide the unimportant things, right? So it's not just about security, it's about hiding irrelevant information. So this is a good software design principle to hide information as well as a good security principle. So there's an example where it's both. And this goes all the way back 40 years now. If you make information available, we will use it. Programmers cannot help but use information. If you make it available, we will use it. So don't expose anything that people will use because they'll start depending on it, right? So good API design hides information. Don't make information available that you don't want people to use. So if you think about software design, we have this idea that there's a spectrum. And if you have too little information available, you can't do anything. But if you have too much information, then you end up with unnecessary coupling. Things get tangled together because you're using things that you shouldn't really be using. So somewhere in the middle, there's the kind of just right point where you have enough information to do something, but not so much information that you've got extra information you don't need. So we have words for this in software design. We have interface segregation principle, right? Don't put things in your interface that other people don't need. And for domain-driven design, there's the idea of a bounded context, which is a boundary where you only have things inside this and you don't care about things outside it. So it's a very important software design principle. Now, in security, they have the same spectrum, right? If you have too little information, you can't get anything done. But if you have too much information, then that's a security breach, right? If I give you everybody's information, that's bad. So again, there's a point just right in the middle where you have just enough information, but not too much information. And the security people have a word for this too. They call it the principle of least authority or least privilege. And I'm going to call this POLA, P-O-L-A, because it sounds nicer than something else. So principle of least authority, very important. Now, if you notice, these two diagrams look very similar. The security diagram and the software design diagram are very, very similar. So we can learn from security and apply the same idea to software design. The idea is you have the principle of least authority applied to software design. So in good software design, we have this thing called an intention revealing interface. The idea is it's supposed to show you what you can do and not let you do what you can't do. And we want to minimize coupling. We don't want things to be tangled together, right? We only want to have very clear relationships between things. We want to have explicit dependencies, right? These are all good software design. And all these are about minimizing your surface area, minimizing what you expose to the outside world so that people can't do bad things, right? And security is exactly the same. We have this principle of least authority, which is, again, it's about minimizing your surface area to this time it's about security. It's about reducing people doing bad things. But the principles are exactly the same. You don't want people to do things that you don't want them to do. So whether that's good design or whether that's good security, I think they're interrelated. Good security and good design and good security. I think they're very, very similar. We can learn from each other. So security-aware design. Now this word authority I'm using. Authority is what they call what can you do? What are you allowed to do? If I have the authority to go into a room, if I have the key to a door, I have the authority to go into that room. If I have a key to a car, I have the authority to drive that car. If I don't have the key, I don't have the authority, right? So that's the word authority that I'm going to use. And you have to be very careful with software to not give too much authority. You do not want to give me the authority to delete the entire hard drive, right? You don't want me to delete every file, that you don't want to give me authority to access your credit cards. That's too much authority. So in security design, we always assume that people are evil and bad and are trying to steal your information. So security people are always thinking about that all the time. So, but here's the thing. There are stupid people and there are evil people. And there's not a lot of difference, because a stupid person can also delete the entire hard drive, and the stupid person can also accidentally leak the credit cards, you know. So in practice, malicious people and stupid people, you have to protect against both of them. So the evil thing is security and good design. Good design stops people doing something stupid, right? So you have to watch out for those people. So we should do this, even as software designers. We should think about, how can we stop people doing things stupid with us? And by the way, stupid people includes me, you know, because 6 months from now, I might do something stupid because I'm tired and I might make mistakes. So we want to stop ourselves making mistakes. Okay, so this is where Polar comes in. It's a very good software design guideline as well as a security guideline. So we'll see in a minute, this forces an intention revealing interface. It forces you to only expose the things that you want people to do. Right, so let's talk about capability. So what is this capability thing? So let's say that I'm calling some sort of API, right? And I make a call to the API, and the API says, I'm sorry, you know, that was a bad call. You passed in the wrong parameters. And then I try again, and it says, sorry, Dave, I'm afraid I can't do that. You know, we have this thing where I make a call to the API, and the API gives me back an error message. And that's, you know, quite annoying, because it's not always obvious what did I do wrong, you know? So rather than telling me what I can't do, why not tell me what I can do, right? It's a different way of designing an API. And this is what you might call an intention, again, an intention revealing interface. What are the things I can do? What am I allowed to do in my code? And if you think about it, this is exactly how a key works in a lock. If you give me a key, I have the ability to open the door. And if I don't have the key, I don't. And that key is the software version of that is called a capability. I have the capability to do something. So I'm going to use the analogy that it's a key. Right. So if I think about a capability-based service, you know, I log into the service and it gives me back a bunch of things I can do, right? Rather than just having an API, it says, here's 6 things you can do. And I use these keys to go into another room, right? So, okay, I'm going to pick one of these keys and I'm going to go into a different part of the website. Now, in that part of the website, maybe there's only 2 things I can do. So I have 2 different keys. You know, one of them might be log out, one of them might be go somewhere else. But at each point, there's only a few things I can do, and they are kind of given to me as capabilities, as keys of things I can do. So the nice thing about this is, what can I do at any given point? That's available. It's made explicit to me. It gives me the keys. Maybe there's no keys. Maybe I can't do anything, and that might be perfectly valid as well. So let's look at a real example of this. This is a game, tic-tac-toe in American, and noughts and crosses in English, and in Russian, I'm sure it has a name, I'm sure everyone knows this name. So let me show you 2 different ways of implementing this game. Right, so the first version is, well, I'm going to implement it like this. Let's see. The first version is that I have a request, and this is F# code, by the way. So I have a player, I'm going to make an X or an O, and which row do I want and which column do I want. So that's my API request, okay? And if you're not used to F#, don't worry about it. I'm just using it for example, but this looks very much kind of like JSON, so not a problem there. Now, the response that I get back from the website would be something like keep playing, or, you know, somebody won, or the game is a draw or tied, or something like this. So that's the input, that's the request, and that's the response. And this is probably how most people would design this game. Okay, so let's do a demo. I'm going to switch over to Visual Studio now and do a demo of this code. Right, so this is the role-based, or I'm calling it RBAC. Right, so I think hopefully everyone can see this code, and maybe make it a little bit bigger. So this is my API, and I want to make a move with the API. So the move I'm going to make is that player X is going to move to the top left position. Okay, and I get back, the result is keep playing, and there is my board. Okay, so now player O is going to move to the bottom left position, and I run that, and I say keep playing, and there it is down in the bottom left. And now player X is going to move to the top right, and there it is up there. And now player O is going to move to the middle. Whoops. And there we go. So there's player O. And then player X is going to move to the top center. And with a little bit of luck, there it is. They got 3 in a row, and the game has been won by player X. Okay, now here's the problem. The first problem is that I might have a bug, and the player O can say, I'm just going to ignore it. It says you won the game, player X won the game, but I'm going to ignore that error. I'm going to ignore it and just keep playing. And I'm going to play in the bottom right. And look, I've played down here. And then I'm going to play in the bottom center as well. Now, it should be somebody else's turn, but I'm going to play twice as player O. Now, look, I've got 3 in a row down here. And now it says that player O won. So I have a serious bug in my design. So this is, but the problem is it's really hard for me as a user. I'm not prevented from, it's very easy for me to discover this bug. If I have a bug, the client can like try different moves and try and find a breach. So it's a bad design in lots of ways, but it's also a bad insecure design as well. So now let's see if we can fix this. Okay, so the problems we had here is the player can play a move already, a player can play twice in a row, a player can forget to check the response. So one of the problems is that the player, the client side, has to understand the rules of the game as well. They have to understand all the things you are allowed to do and what you're not allowed to do. And if you have a malicious client, they can just ignore these rules and try playing twice and trying all these things. So this is not an intention revealing interface. I have to trust that the client knows what they're doing. So there's the thing. If a developer has to think about the implementation, then you don't have encapsulation. If I have to understand how the rules of the game work, it's not a very good interface. Right? I have to understand when I can keep playing, when I can't keep playing, and all that stuff. So let's look at a different implementation. So don't tell me that, don't let me do a bad thing and then tell me off. I mean, that's what's happening. There's nothing in this API that says you're not allowed to play this move anymore. It says, yeah, go ahead and play this move, and I'll tell you if it's not allowed. Right? So we're going to do the opposite thing. We're going to say, make illegal operations unavailable. I am not going to let you play a bad move. How can I do that? How can I stop you from doing that? Right, so this is the way we're going to do it. We're going to use a capability-based approach. And what we're going to do is when you start a new game, I'm going to give you back nine capabilities. And then you're going to pick one of them, right? 9 available moves. You're going to pick one of them. And now you get back 8 available moves. Okay, and then you pick another one. And now you get back 7 available moves. And now you pick another one and you get back, 6 available moves, and so on and so forth. And eventually you make a move which wins. And now you get back no moves because there are no more moves you can make. So this is the difference between a capability-based design and a kind of standard API. So the code actually is the design is slightly different. We have this concept of a capability, which is an ability to do something. In this case, it's the ability to make a move. So when I call this capability, it's going to make a move for me and give me back a response. Right? And so if you're in C# or something, that's equivalent to a func. It's a func which returns a response. So it's just something you can call. I mean, it is just a function that you can call that will return a response. It will just play the move for you. And then the actual response itself, it says, if you can keep playing, I will give you back a list of capabilities. Rather than just saying, oh yeah, you can keep playing, I will say, yeah, keep playing, and here are the 7 moves that you're allowed to move. You're allowed to make. The 2 moves you're allowed to make, or the no moves you're allowed to make. Right. So this is a very slightly different API. Right, so this is this important thing. The response contains all the moves you can make on the next turn. So you don't have to understand the rules of the game. All you have to do is pick one of these moves and make it. You don't have to understand anything else. And then, of course, the initial moves is just the list of moves you can make. That's it. Right, so that's the entire API. That's a capability-based API. So I'm going to do a demo of this in a minute, but you can see it's not any more complicated. It's just a slightly different way of thinking about it. So notice no more request, right? When I call this capability, I don't pass in the player and I don't pass in the position. I'm not allowed to, I don't have that freedom. I have to pick one of these moves. The moves are baked in. Which player is moving and where they are moving, that is baked into this capability. So I cannot change it. I have no choice, right? I cannot make a mistake. Right, so let me do a demo of how that one works. So in a capability-based API, I'm just going to load this up here. This is F# interactive, by the way. Very nice. Oh, okay, I'm going to create a new game. Now what happens is I get back, it says keep playing. When I get a whole bunch of capabilities, right? Each of these capabilities and have a which player is playing and which position is that going to be played. So this is my capability. It's a function that I call. So I basically call this function. Okay, so I'm going to call this function. And now I've made the move. And if you count these, I've actually only got 8 capabilities left. And what you can't see is that this is what you can see now. This is whichever one I pick, it's always going to be player O. Player X cannot play. There's no capability for player X to play anymore. And that top left position is not available. I can only play in these positions. I cannot play in that position. That is not available to me to play anymore. Okay, so now I make another move. And now I've got back 7 capabilities, and every single one is for player X. And again, certain moves are not available. And if I play another one, now everyone is player O, and you can see the board is being filled up. And let me play another one. Now the board is filling up, and there's only a few capabilities left. There's 5 capabilities left. And if I play one more, that's it. Notice there are no more capabilities. The game has been won by player X, and there's no more capabilities. I cannot play anymore. So if I try and keep playing, if I say, well, I'm going to try moving this one, it says the game is over. There is no more moves I can make. All right, so let me show you some other things you can do. Let's say I start a new game. Right, now that capability, I've moved the top left, so it's not in the list anymore. So if I try and move it again, it says there are no available moves. You cannot play that position. That position's already been played. And even if I try and do a brute force thing, it's like I don't care what the API is, I'm just going to literally force that to be done and try and call that same capability twice in a row. Like it's like, okay, you gave me a capability. I'm going to remember that capability from last time and try and run it again. And if I run it again, I get an exception. It can only be played once. So this is, a much safer design than the original design, I think. So that's that demo. So in this design, let's look at the errors. Well, you can't play an already played move. You can't play twice in a row because I never got to choose who was the player, right? The capability had that inside the capability said it was player X or player O. I couldn't choose, and I couldn't choose the position. I had to pick one of these 9 functions and just run it. And in the first one, remember, I could just ignore the response. They said the game was over, and I could say, okay, I'm going to ignore that and just keep playing. You can't do that in this one because when the game's over, you get no capabilities. There aren't any more capabilities to run. So I literally cannot keep playing. So we've solved all these problems with a capability-based design. So I think that's much nicer. So is this good security, or is this good design? Is this stopping people doing something bad, or is that like that envelope, where you can't see, or is it good design? Is it making sure that people can only do good things, making it easier for people to do the right thing and hiding all the things they don't need to know? I think it's both. I think it's both of these things. So if you're familiar with this abbreviation, Hypermedia as the engine of application state, this is exactly the same thing. So let me demonstrate this. If you were doing a website, you could use exactly the same technique. So let me give you a demo. And the whole point of this idea in a website is that the client, again, does not need to understand the logic. The client just has a whole bunch of links, and it picks one of the links and it runs one of the links, or navigates to one of the links. The business logic is the client doesn't need to be coupled. If the client has to understand how the website works, the client is coupled to the website and it's tangled up with the website. The whole point of a distributed system is these things are independent, they're not tangled together. Right? So this is what a classic RESTful system is supposed to be. So sometimes you see, RESTful systems that look like this, and you have a post and a get, and this is wrong because you can guess what the API is, right? I can guess that it's customers, and I can guess that it's a number of stuff. This is actually a security problem, and there was a recent, every day there's security problems where people can just run through the numbers and get other people's customer data and so on. But even if it's not a security thing, if I ever want to change my API, a lot of code will break because it's hard coded to use these URLs. Right, so it's going to be really hard for me to change my clients. If I change my API, all the other clients are going to break. So it's very fragile. So what the API should look like is this. This is the way your API should look like. And then think, well, how am I supposed to know what these URLs are? And the answer is you have to parse them from the page. You get back a response and you look at all the URLs and you figure out which is the one you want, and that's the one you go to. But you don't know what they are in advance. You can't guess what they are. So this is a capability-based design. So let me show you in tic-tac-toe. This is how you would come back. You'd have a bunch of maybe a JSON, and each move would be a URL that you can make. And it would have some sort of weird URL that you've no idea what it is. So I look along and I say, well, I want to play the left top. So I'm going to find the one which has this description in it. And then I can use this capability, but I can't choose. I can't say I want to, I can't pass it in as an API. I have to find the link that works for me. So let me do a demo. So these are capabilities. This is a web-based capability system. So let me do a demo of this one. Right, so here is my new game. Let's show this a bit more. So this is coming back as HTML. And if I want to move to the left top, what I do is find the description, and then I find the link. And in this case, I'm just going to paste it in here. I'm going to say I want to play that link. Now I get back some more HTML, and notice that the top left one is not there anymore. There's only 8 links. Okay, now if I want to play the bottom left, I go down here, finding the bottom left, and there it is, this one. So I take this URL, I paste it in here, and bam, now I get 7. And if I want to play the top right, I find it there. Well, that's top right. So I take this URL. Now notice again that at no point do I decide whether I'm playing the X person or the O person. That's hard coded into the game. You see, I've been switching between X and O. I have no choice about where to play and who to play. And notice that I can't play this one again. This link, if I try and run this link again, I'll get another of these errors. Capability is no longer available. Right, let's play the middle center, which is this one. Okay, and then I will play the top center, and that should win the game. Good thing this is an easy game to win. And there we go, game won by the player. There's the board. And again, now there are no more capabilities, there are no more links that I can run. So again, this is if you're doing a website, this is a great way of doing it. All I have to do is parse the links. I just have to, all I need from the client's point of view, I just need to be able to read these descriptions and find which link I want to run. But it doesn't have to understand the rules of the game. Okay, back to the demo here. So good security and good design. So is this hypertext version, is it good security because it stops me doing a bad thing? Or is it good design because it makes it really obvious what I should be doing? I don't have to think. As the user, I do not have to think about what I'm doing. I can just pick one of these links and run it. Okay, so once you have this way of thinking about capabilities, there's all sorts of cool things you can do with them, which is more than just calling a function. So you can use them inside your code. You don't have to just use them for APIs. You can use them inside your code. So let's say that I want to read a customer from a database, okay? And so I might have like an API layer and some business logic and a database. So which component in this model decides, are you allowed to read the customer? Should it be the controller? Should the controller decide? Well, the problem with having the controller putting the barrier there is that it's quite possible for somebody to bypass that controller and use another controller and hit the database. So, that's not very good. On the other hand, if you have the database decide, that's not very good either because it doesn't have the context. It doesn't know what circumstances the database accesses. So it's tricky to put logic about who's allowed to see what. So this is a tricky problem. What most people do is they have a separate module called a global authorizer. And this global authorizer is the one that decides whether you're allowed to talk to the database. So in the controller, I go to this global authorizer and I say, can I talk to the database? And it decides, and then it gives me an authority to talk to the database. So my question is, how many people use this technique to provide a global authorizer for their database access? And I bet you're all going to say no. You're going to say, no, I would never do that. That's way too complicated. What happens if I call it dependency injection? So now it's exactly the same thing. A dependency injection is supplying the ability to talk to the database. So let's look at an API. So here is a controller that's going to read the database. And what we do is typically in the constructor, we pass in some sort of interface, right? So there's a customer database interface. We pass this in. This is the authority to access the database. That's exactly what that interface is. It gives you the ability to talk to the database. So I call it a global authorizer and you call it dependency injection. Same thing. And then later on in your code, when you use that interface, right, I'm going to get the customer from the database. You call that, using the interface, and I call it using the authority. I call it using the capability, right? So this piece of code here, this is where you're using the authority that you're given earlier. So you just think it's calling a method, and I think it's, using the authority given to you by the authorizer. So if you think about it this way, it's a very different way of thinking about what you're actually doing, even though your code hasn't changed. So one of the problems with dependency injection and using interfaces is that you often get way too much authority. How much authority do you actually need? Right. So here's an interface for accessing a customer database. So I have a way to read the customer profile from the database. Okay, that's good. Maybe I have a way to update the profile. Well, okay. Maybe I have a way to create an account. And what about deleting an account? And what about changing the email? And what about changing the password? What about launching the missiles? Like these things, do I really need all that stuff? Should some of these things even be in this interface? So yeah, I mean, I need this one. That's the one I need for this particular use case, for this story. That's what I need. I probably don't need to have the ability to update the password. Why do I need to update the password? That's not even part of the, the use case. And why do I need to launch missiles? That's really bad. I mean, that's way too much authority. That shouldn't be in this interface. But you know how it is. It's very easy to add things to an interface, and the interfaces get bigger and bigger and bigger, right? We know how that is. You start off with a small one, and it gets big. So let's not do that. Let's focus, and this is why this is a design technique. Let's focus on only having the authority I need to do something. So if we do that, let's cross everything out, right? Let's get rid of everything we don't need. And now this is what we're left with. We have an interface that only does one thing. This is all the authority I need for this particular controller. Okay. So this is a much better design. So it's a safer design, but it's also a better design because I don't expose things that I don't want anyone to use. Now, if you have a whole interface with just one method, that's fine. That's the object-oriented way of doing it. If you're a functional programmer, it's just the same thing as a function. So whichever way you want to do it, a function or an interface with one method, basically the same thing. Right, so so here's my tip is don't inject interfaces, inject capabilities. Only pass in the things you actually need for this particular thing, and don't pass in anything you don't actually need. Right, now, so this is the functional version. I am passing in just the authority to read the customer, right? So instead of passing an entire interface, I'm just passing in a function. So I'm injecting a function, and then I'm using that function. So you can think of this, it's just a function, but if you, from a design point of view, you're thinking about authority. What am I allowed to do and what am I not allowed to do? In this case, I'm allowed to read a customer. I'm not allowed to do anything else. And I can't do anything else because that interface, there's nothing else I can do. This is the only thing I can do. I cannot have a bug where I accidentally change someone's password or I accidentally launch the missiles because I do not have that capability. I do not have the ability to do that. So this leads to a design which is a vertical slice design, right? So you have a particular use case with a controller and all this stuff, and it focuses on doing one thing, right? And you just inject what you need for that one thing. And when you have something else you need, you have another thing you need to do, and you just inject what you need for that. And you have another thing you need to do, and you just inject what you need for that. So if you take this approach to designing things, you end up with these vertical slices. You don't, instead of having horizontal slices like this, you have these vertical slices like this. And this is a much better way of doing design, I think, because it's a lot easier to focus on what's important. Each piece of code is independent and you can change them separately, and they only focus on one particular use case or one particular story. So this vertical slice approach, I highly recommend you do this approach if you're not doing it already. Okay, so what else can we do? One of the problems with the database authority is we have the ability to access any customer, right? So you give me this database thing and I can access this customer, but I could also access somebody else's customer, and that would be a security breach, right? So how can we prevent that from happening? We need more fine-grained control. Now, there's lots of different ways of doing fine-grained control with role-based access control, but let's look at a capability-based way of doing it. So here what we're going to do is I'm going to go to the global authorizer, or my dependency injection system, if you want to call it that, and I'm going to say I want the authority to read this particular customer, nobody else, just this one. And if I get that authority, then I can read the customer, right? So what I'm doing again is I'm going to see, do I have permission to read that customer? And then if I do have permission, then I can keep going. So again, nothing special from a code point of view, but it's just a different way of thinking about what you're allowed to do. And then at this point, I can then, okay, yeah, I do have the ability to read the customer. Let me read the customer and return the results and so on. So notice that when I read the customer, I do not pass in the customer ID. I cannot read any other customer. I can only read this particular customer. and that prevents all sorts of bugs. You know, those errors where you pass in the wrong customer and you accidentally have a breach, that cannot happen. Okay, so another really cool thing you can do with capabilities is they can be transformed because they are just functions. And so functions can be turned into other functions. And this is a really nice piece of design as well. So it's a very common thing to have something called a capability transformer. And this is a function that turns capabilities into other capabilities. And normally the new capability is more constrained in some way. So there's less things you can do with it. So for example, we want to do certain business rules with capability. So a capability is like, okay, every time you use this capability, I want you to audit it. I want an audit trail. Who ran it? Who called this capability? When did they do it? That's really easy to do. What about a capability that you can only use it in office hours? If anyone uses this at 2 o'clock in the morning on a Sunday, that might be a hacker, right? I want to make sure it's only used in office hours. That's very important. What about a capability that's only used once? So I especially if I lend it to you, I lend you my key, you can borrow my car today, but you can't borrow it tomorrow. You can only borrow my car once, right? That's a really useful. And sometimes you give people a key, you know, in the real world, you give people a key, and then if you change your mind, you don't like them anymore, you have to like change all the locks. But in software, if I give you a key, I can self-destruct that key remotely because it's software, right? So I give you a key and you can use it, and then if I don't want you to use it anymore, I just hit the button and that key blows up. So that's really useful technique as well. So that's what they call a revocable capability. So I give you a capability, and it also gives me a destruct button that I can destroy the capability with. So these are the ways that you kind of sort of transform capabilities into new capabilities. Very, very nice. And even something simple like a capability that's revoked after 10 minutes. So this is a good one if you send a password reset code in an email or a text message or something, and it's like you have to use this in 10 minutes. This is really easy to do with a capability system. This is really easy to implement. You just run it through this transformer, and it handles that. So let me give you a demo of some of these transformations that you can do. Right, so capabilities as functions. So here's my capability, and all it is, it's going to be, getting given an ID, giving back a customer. So here's my this is my database. Very sophisticated piece of code here. You give me 1, I'll give you back Alice. You give me 2, I'll give you back Bob. So that's my high-tech database implementation. So my basic capability is just getting the profile from the database. That's really easy. So if I ask it for customer number 1, I get back Alice, and I ask for customer number 2, and I get back Bob. Right, now let's add some auditing. So what I'm going to do is I'm going to pass in a capability and also some extra information. And don't worry about this code, but you can just see it's a few lines of code. So it's not really, I'm not trying to explain how this code works, but the idea is it's a few lines of code. I can transform this capability into a new capability. So I'm going to start with my basic capability, and I'm going to add some auditing to it. Right, that's my audited capability. Now, if you look at the signature, it says you give me a custom ID, and I'll give you back a profile. It has exactly the same interface as the original one. The original one said, give me a custom ID and I'll give you back a customer profile. This one has exactly the same interface. So I can, anywhere I use the original one, I can use this one. They're interchangeable. But unlike the original one, this one is audited. So when I call it, it says, I use this capability to get Alice, right? So I logged that. And if I call it again, I get another timestamp. So, timestamp changes. Very good. What about bait limiting? What if I only want to do it once? So again, you don't worry about the code, but I just want to show you the code is just a few lines of code. So my new once only version. So I'm using the audited capability, and I'm now making it once only. So it's going to be audited, and it's also going to be once only. So if the first time I call it, right, I get the answer and I get the audit. But if I try it again, it's boom, exception, it's only allowed once. So I can do this to any capability. This only once function is a very generic function. It will transform any capability into an only once capability. So these are generic kind of library functions. They're not, they're not hard coded. Here's my revocable one. Again, just a few lines of code. And now when I make something revocable, I get a pair of things back. So the first one is my revocable capability, which I'm going to run. So yes, I'm going to run it again. I can run it over and over. And then I'm going to say, okay, I don't trust you anymore. I'm going to destroy your capability. And now, if I try to use the same capability again, boom, capability has been revoked. So that capability no longer works anymore. So this is very good when I'm delegating capabilities to other people. I can give it to them and then I can stop trusting them. So because capabilities are basically just functions, you can do all sorts of cool things with them. And of course, you could see I could have one that only worked in office hours, only worked for 10 minutes, all sorts of things I could do. Right, so let's see what else we have here. One other nice thing about capabilities is they're very easy to delegate, right? So if you think about access control, right, a lot of times we talk about security, we try to stop people doing things. Like, I don't want to let you go into this room, right? They have a lock on this door. Or maybe I only want you to do some things, but I won't let you do other things. Or I don't want to let you in anymore. So all the things that we use, things like a lot of people, you use swipe cards in an office to let you into the building. I'm sure a lot of people have that kind of thing. And these are all about stopping you from doing things. But it's quite nice to be able to give you the authority to positively do something. That's very convenient. So I can grant you the ability to do something. If I want to let you borrow my car, I can just give you my car key and I can give you the authority to drive my car. I don't have to give you my swipe card. One of the problems with swipe cards is that it's very hard to share part of the swipe card. I have to give you all my authority or none of it. I can't give you part of my authority. So this kind of thing is very nice because being able to grant access to certain things only is a really nice feature, and it's quite hard with most security systems. This is very hard to do. But on hand with the keys, it's really easy. A lot of people in the old days, before you had swipe cards, you had a bunch of keys, and some of the keys, each key did something different, right? So I could give you one key, but not give you all the keys. So this is a set of capabilities, and I can delegate by giving you some of the keys. Right. So let's say I have a bunch of keys, and I want you to get some office supplies. I want you to get some paper from the office, right? So I can give you one key, and you can open that door and get me some more paper. But that key will not work on the secret files in the office, right? Each key is different. It's a different door, a different lock. And so keys are great for this. And sometimes I see people with swipe cards, and it's like a person can't get into this room, and they lend them their swipe card to get in. That's really bad security, right? So keys are actually nicer in many ways. The reason why keys are not so nice in the real world is because they don't self-destruct. But in software, we can make them self-destruct. So here's an example of delegation of authority. You've probably seen this. This is Google Docs. And I have a document and I want to share it with you, right? So I basically get a link and I send it to you in an email. And now you can see that document. That's really easy to do rather than having to add you to Active Directory just so you can see this one document. And if I add you to Active Directory, then maybe you can see all my documents. I don't want you to see all my documents. I just want you to see this one particular document. So sharing a link like this is so much easier. This is delegating the authority to view my document, just this one. And here's Dropbox. I send you a Dropbox link or a Google Drive link or a OneDrive link or something. I just want you to see this one thing, and I can just send you a link. And this is a much nicer way of doing things than any other way of doing things. So I'll give a little real example here. This is the controller API, and I'm going to update my database again. And I'm going to go to my global authorizer. And the global authorizer, my dependency injection, is going to say you can read one customer. Okay, fine. Now, typically in most of our software, if I update the customer, I would say, okay, I'm going to send you an email saying you've been updated, right? You've got a new email address or whatever. The email server will often have permission to see all the customers, right? It has global authority, and that could easily be a bug. In fact, I have personally been involved in a bug where our email system sent out an email to every customer in our database by mistake, and they shouldn't have done that. But it was really easy because the email system was literally reading records from the database, and it accidentally read all the records rather than one record. And that's because the email system had global authority. So what we want to do is we want to get the authority to the controller, right? This is bad. We want to give the controller the authority, and then the controller delegates that authority to the email. So the email can only read the same customer that the controller was working with. And that way you can't have any mistakes where you accidentally read the wrong customer, or you read too many customers, or you have a data breach or anything like that. So that's a much better model of doing something. And one nice thing about delegated capabilities is you can transform them just like other ones. So, at the beginning, I have capabilities. I can do this stuff, and I can give some of them to one person, and I can give some of them to another person. And each of the capabilities I give can be transformed. So the first person, I'll say, okay, you can only do it once. And for the other person, I say you can only do it during office hours or something, right? So because they're capabilities, because they're delegated, I can transform them just like I can use the same techniques that I did before, which is very nice. So I'll do a demo, and then that'll probably be the end of the talk. So hold on a second, where are we? Right, let me do a quick demo of delegation. Right, so here's my capability. I have a capability to read a customer and a capability to update the customer. And then I'm going to have this only once capability that I had before. Right, so in the database, this is my code to read a customer, and this is my code to update a customer. It's just going to do a print, right? So it's not a real database. So read a customer and update a customer. That's not very important. Now here is the email service. I'm going to send an email saying, hey, you've just updated your record, your name in your database, or your email's just been changed or something. So rather than having the capability to read any customer, I'm going to pass in as a parameter, I'm going to pass in the capability to read a particular customer. And the customer ID is not being passed in. I just call it, right? I say, okay, you give me this capability, and I will just run this capability to get the customer profile. But I don't even know what customer it is, right? I cannot really make a mistake. I can't ever read the wrong customer. Okay, now in the controller is also given some capabilities. So I'm going to unpack the capabilities, and then I'm going to update the database and log that. And then I'm going to create a new delegated capability, and that's going to get the profile just for this ID, and then I'm going to call it only once. Right, so I guarantee this email it can send this email, it can read this customer once just to send this email, and it can't do anything else. So this is a much safer way of writing the code. And what's nice about it is also much more obvious design. It's very clear what's going on. So finally, I'm going to create the controller. I'm going to get all my capabilities, and I'm going to create the controller. So let me just load this whole thing up. And there's my controller. This is obviously it's kind of silly code, but there you go. It did actually work. It loaded up Alice. It updated the database, and it sent email. And if I change this to customer 2, it sent the email to Bob. And I updated Bob's name to Alice. I shouldn't update names Bob to Bob 2. So there you go. That is capabilities. So just to finish up, Good security and good design. I think if you focus on good security, the design becomes a lot better because you're not exposing information that people shouldn't be accessing. And it makes sure, like I say, like with the vertical slices, you get this much more modular architecture because the different pieces, they don't know how the other pieces work. All they know is what's been passed to them as capabilities. There's no dependencies between them. Using this principle of least authority is a really good design principle, I think, because from a security point of view, it's, we don't trust you to do the right thing. But from a design point of view, it means that you can't make a mistake. It's a lot easier for people to use. They don't have to read the documentation and say, oh, don't call this API in this situation and don't call this API. If I'm using this capability-based thing, it's like, it makes it much easier as a user to use the system because it just gives me back what I'm allowed to do. And I don't have to read the documentation all the time. And again, it's much more intention revealing. I don't, in the tic-tac-toe example, the tic-tac-toe did not have to understand the business rules. All I had to know is how to pick one of these links and run it. In the original version with the kind of simple API, it had to know what the rules were. Like, you can't play the same move twice. It had to know that. It had to know that you had to alternate between players. It had to know that rule. A lot of things it had to know. And in the capability-based one, it didn't have to know any of that stuff. And the interfaces are much more dynamic. If I want to add a new capability or take capabilities away, I just give you back more or give you back less. And, it just makes everything much more decoupled. So capabilities is a great design for that. So that's the end of my talk. Thanks very much. As I said, I'll put the slides and the video up on my website. And I think we have time for some questions.
Yes, we already have one, and
Okay.
I have a more specific.
Mm-hmm.
So Alec is asking, are there any disadvantages of this approach? So I'll let you answer this question first, and then I've got a more specific one from myself.
Okay. The disadvantages is a bit more work. I mean, it's more work for the person implementing it to do this. It's a lot easier to just expose an API and tell people you got an error. So it might be overkill. It might be unnecessary. I think it's worth investigating as a technique. So I think it's something to have in your toolkit. It's one of the techniques you should understand. Should you use it all the time? Probably not. But sometimes when you do need to use it, it might be a really good thing to know about. It's just another thing to know about that might be useful.
Okay, sounds good. So a more specific one. When you talked about the tic-tac-toe example, I was thinking, what if this is a more advanced version of tic-tac-toe game? Let's say it's 10,000 fields instead of free to free fields. So it might be extremely complicated to calculate how many capabilities are available, especially if we have a lot of input parameters. So basically, a lot of situations when we go to almost infinite amount of combinations of input and output parameters. So is there any workaround about it if we still want to use this approach?
Yeah, I mean, that's a good example where it's probably not the right way of doing something. If you have millions and millions of things, because you basically have millions of capabilities and they're all very similar. So that's probably not a good use. But I'm thinking of more where you only have a few, like if you're on a website, especially a secure website like a banking system or something, you only want to be able to, you want to be able to move money from here to here, but you don't want to let people do anything else. So that's a good situation. But if you have like a video game where you can click anywhere on the screen, that would be a bad situation. That would probably not be the right way of doing it. But even so, you could still have capabilities to limit you. I mean, a good example is the file system. A lot of applications need to read and write files. But rather than saying you can read and write anywhere on the file system, you can constrain it so you can read and write in this one directory. And that would be a good example of capability. It's not saying what you can read and what you can't read, what kinds of files you can read and write, but it does say you have to be within this one directory. So that's a capability-based approach to restricting you to certain kinds of things. It's still leaving you lots of freedom to do other things as well.
Actually, that's what modern operating systems do.
They do. They use capabilities. Now, it's a slightly different. They're using the word capability slightly different from the way I do. So operating system capabilities are slightly different from this, but I think they have the same idea underneath it, which is that you have a capability attached to a file handle or something. But yeah, not this from a technical point of view. I think they are slightly different, and I'm using it as a design idea, and they're using it as a security idea as well. But I think from a design point of view, it's good.
Yeah, probably yes. I was referring to something that is extremely popular in macOS right now, or on iOS, when every application needs to get access for your camera, or for the access to your private folders, so like your user folder or something. So this might be a good example.
Yeah.
So I was making some notes during your talk also. Do you have any comments on the relationship between this approach and the so-called interpreter pattern? I don't want to pronounce the word free monad here, but essentially, I kind of see a relationship here, especially when you mentioned HATEOAS. So you can build a dynamic API which can be updated, so without the recompiling the actual clients. So this is somehow similar to me.
Yeah, I think so. I mean, it's a very interesting approach. I never thought of them as similar, but you're quite right, because in the interpreter model, you are given, 5 or 6 or 10 operations that you can do, and you are free to combine them. But what you can do is limited to those, operations that you are given in the interpreter. So yes, that's a capability-based design, and it's very flexible, because you can do all the things you can do. You can do the same thing with interpreters. You can transform the operations to give you input and output, or to give logging, all that stuff, and it helps with the design, because it tells you what you can do. It doesn't say, like a good example, rather than saying you can't do this, it says these are the 5 things, or these are the 10 things you can do. So yeah, I would say actually it is similar. Yeah, that's a good analogy. Yeah.
Or it could be even a combination when you build your system on top of the interpreter pattern, and at the same time you're not allowed to use any kind of command in any state, but instead of it you ask for capabilities, and based on capabilities you choose from the available operations.
Yeah, exactly. Yeah, interesting. That's an interesting idea. I'd like to. That would be worth looking at. Yeah.
Good. So I don't see any other text questions on chat. So why would we go to the Q&A session, where the audience can unmute themselves and probably ask questions online.
Okay.
So thank you for the talk. Andrew, are you here?
Thank you.
Yeah. Hey, Scott. Thank you very much for the awesome talk. It was pretty inspiring. Yeah, I'm agree with Mark. So it's time for the discussion zone. So I invite you and all the people in the audience who have any question about F# or designing or whatsoever, or if you just want to chat with Scott and discuss anything, just go to the Zoom call. The link is in the chat, and so have fun.
Thank you. Thanks, everyone.
Thank you.